Okay. Focus please, everyone. First, what does optimization mean to you?
Yeah, as good as possible.
Sorry?
Efficiency, as good as possible.
As good as possible. Eh? Efficiency, good. What else?
That's about it.
That's about it. Alright, okay. What about thinking about, let's say, if I am, I have a business.
Yeah,
Alright?
as much money as possible.
Yeah, efficiency, getting as much as possible. What about things like minimizing loss?
Cost.
Minimizing cost, yeah, minimizing loss. Absolutely. So, what we're going to do is think about how we are going to use calculus. Especially yesterday, you learned the sign test. How are we going to use a sign test to work out the optimum solution? What is the optimum solution? Think about optimum solution as in maximum, minimum. Alright? Here, about optimum solution, you will not be looking at the horizontal point of inflection because there's no maximum minimum there. Correct? Yeah? Horizontal point of inflection, if you draw a graph, is something like this or something like this. Alright? The horizontal point of inflection, that's no minimum maximum, is there? Of course not. Whereas something like this, you have maximum, something like this, you have a minimum. Or even something like this, you would have local maximum, local minimum. So now you're going to think about how to apply what you learned yesterday, the sign test into this optimization problem. Alright? So, what you need to know after today is link the idea of stationary points to the idea of optimization. Like I say, maximum or minimum. Define a calculus-based approach for optimization to solving practical problems requiring an optimal solution. So I'm not going to go through step by step how to do the sign test again. What I'm going to go do straight away is talk about optimization. Alright? Mathematical optimization is the process of finding the optimal values of a function, which may be used to model a practical situation. When we talk about optimal solutions, we need to think about the best solution. In particular, optimal solutions will often be maximum or minimum values, depending on the context. Alright? Like I said, depending on the context, could be maximum, could be minimum. For example, how many items will be needed to be sold for maximum profit or minimum loss or minimum cost? Alright? What are the dimensions of a geometric figure in order to maximize the volume or minimize the area? That sort of things you got to think about optimization. So I'm going to show you 3 examples today, which is in front of you. I can tell you example 2 will be the A+ question, will be the hardest question, example 2, in this situation. Alright? So I want you to start thinking and think how you would link what you have learned from yesterday to today. Alright? Now, starting off with a function like this. Alright? You can see that there's local minimum and local maximum. Alright? So, here, what we have done is, what you've learned is learn optimization of function by finding the stationary points, maxima and minima. So in that graph, that function, I will show you where the local maximum is and the 2 local minima. So that will be the optimal solution when you're looking at optimization problem. So maximizing something for the domain, minimizing something for this domain, or minimizing something for this domain. Alright? Again, it could be domain-based as well. There are situations where you think about the domain has to be only greater than 0. The solution does not extend to anything which is negative. For example, producing certain thing in a factory. You want to maximize the cost? Yes, you can have negative values because you might be losing money, but you will never produce negative of that product. You will have a positive of that product. Correct? Yeah. Always produce enough. Alright? We'll talk about that in a few minutes. Actually, no. Next example. I think the first one is profit, cost, and revenue function. So you should know from maybe year 9 or year 8, profit is actually equals to revenue minus cost. Correct?
Yes.
Can you really dig deep in your memory? Yeah? Profit is revenue minus cost. So now, read the question. For the number of units, and that maximize the profit, given that the revenue made from n units is that function, and the cost to produce n unit is this function. Alright? So you've got two functions there. How are you going to apply that function? How are you going to use those two functions to come out with a profit function? Alright? Now, in the actual, if you've got a question like this in the exam itself, you will not be given that. We will assume that you know profit is revenue minus cost. Alright? So therefore, if I define Pn, a function, as a profit, can I derive Pn from Rn and Cn?
Yeah.
Very good. Can you write that down first and check your answer against mine? Do that and I'll show you my answer. Now, you have to simplify your Pn, alright? You know Pn should be Rn, take away Cn. Remember your brackets. You must always remember your bracket. If not, you make an error. Yeah, you're all on the right track. So, first step. Derive a profit function. Pn equals to Cn minus Rn. And you should be able to expand and simplify it. Not even expanding it, just multiplying the, oh yeah, this expansion. So multiplying the minus in, yep. Sorry? So you've got bringing the negative in to this bracket. Make sure that you know there's a bracket there. Alright? I have seen people without doing the bracket take away 300 and then plus 1.1n. And the answer is so wonky that it's not funny. Alright? So have a look, remember your bracket. From here, what is the next step? How do you find the stationary point? Sorry? What equals to 0?
The derivative.
Thank you, the derivative equals to 0. So you need to find the derivative first, don't you? Alright, find the derivative. Then I will show you my answer. So work out the derivative and then set the derivative as 0 because it's the stationary point you want. Now, this is the first derivative. And then, of course, if I set it to 0, n is 650. So you need to produce 650 units. Alright? Now, do we know this is maximum or minimum? How do you do that?
Sign test.
Thank you, the sign test. So how are you going to set up the sign test? Recall how I showed you yesterday? How do you set up the sign test? You need to know how to set up the sign test.
You have the value below and after.
Thank you. The value below and after. Excellent. So, you got something like this. That should be, in here, there should be the the first derivative. Now, think about what you want to do here. Less than 650, I will use maybe 1 or 0 or something like that. It really doesn't matter. 1, and you know that 1, if it is 1, this will be minus 0.006, and that is 3.9. Therefore, it's positive. Alright. Greater than 650, let's make it maybe 1,000. 1,000 times this is 6. 6 plus 3.9 minus 6 plus 3.9 is negative. So like I said, you don't need to find the exact value as long as you know it's positive or negative. That's important. That's all you need to know. Positive or negative. Showing your sign test positive, 0 and negative, you therefore know that the shape is that one. It's a maximum. So maximum, you've got positive gradient, 0 gradient, and negative gradient. Think about your calculus. Go back to your calculus. Alright? Think about what is the first derivative. Is the instantaneous rate of change or the gradient at a particular point. And therefore, n equals to 650 is the local maximum. Next, do you all have a class pad?
Yeah.
Grab your class pad out, please. If you haven't got one, I've got 3 here. We need to use your class pad for the next one. Class pad. Now, the only reason I want you to use your class pad is to be able to plot. Alright. Now, you know Pn. Alright, let me write it down on the board. Pn equals to minus 0.003 n squared plus 3.9 n minus 300. Alright, let's go to the next part of the question. Alright, before that, you should always say 650 units will produce the maximum profit. You need the conclusion. Alright, or just a remark. Now, if the limit of the production are between 0 and 100 units, that is between, you got a domain, greater than 0 and less than 800. Of course, it has to be greater than 0 because you have to produce a unit and then you have to produce something. Alright? Find the minimum and maximum profit. This is where you're going to start thinking. Maximum profit, fine. You know n equals to 650. Alright? So therefore, you can work that out. Now, let's use your class pad. Can you actually plot that graph? And I am going to call out my class pad. Alright? Now under class pad, what you need to do is go to graph and table. Alright? Make sure that you clear everything. Clear everything. Now, this morning for a test, someone told me the calculator wasn't working because they can't see the graph. It's basically not clearing this window here. So make sure if you can't see the graph, make sure that you clear the window so that you start from the origin, and then you zoom in to where you need. That's important thing to learn about the class pad. So if you put that in, y equals to minus 0.003 x squared, 3x squared plus 3.9x minus 300. Tap on that and draw the graph. Alright? Now, what you need to do is go to zoom and then type in auto. You see something like this, but you know that something's not right. You've already worked out the maximum of 650, correct? So therefore, let's change the scale. So I want X max to be, let's say, 800. All right? And Y max to be, Y max, what did I work out just now? What was the maximum profit? I can't remember.
650.
No, 650 is the number produced.
Like around 1,000.
Around 1,000, let's say 1,500. All right, thank you. I cannot remember.
It's 900.
Okay, see, you've got to graph something like this. Now, you can tell where the maximum is by going to analysis. G-solve, max. You got the maximum. Correct? You've got a graph here. Now, where does the profit come in?
From the x-intercept.
Thank you, from the x-intercept. So that will be somewhere here will be a minimum profit. These are the loss, correct? Anything below that is a loss. Or the startup cost. When you first started doing something, you will not get any profit until you started selling it and then you started getting some money in. So what you need to do is find out where the x-intercept is. Analysis, G-solve, go to root. Yep. So it gives me x equals to 82.109. Is that realistic?
No.
Okay? No, because you will not be able to produce 82.109 units. So you have to think about the minimum profit is when you produce 83 units. Alright? So this requires a bit of thinking when you solve problems like this. So what the minimum is, you've got to produce, this is when you produce 82 is still below, there's still no profit. So the minimum profit will be just above 83, correct?
Yes.
Yeah? So you can use G-solve if you want, analysis, G-solve, X-cal, Y-cal. You know what X is, you know you want to find Y. So the X value will be 83. So that is your minimum profit, 3.03. Got it? So this is actually a practical problem now. You've got to start thinking where the profit is, where the loss is. The profit is not zero. The minimum profit is when you produce 83 units. Got it?
How'd you get 83?
Because at x-intercept is 82.1 something. So if you produce 82, it will still not be a profit, it will still be below.
Why is the x-intercept the minimum profit?
It's when you start producing.
When you break even.
Alright, break-even point. That's a break-even point. So from here, when you produce the first unit to the 82nd unit, you will not be making any money at all. You're just basically paying off the cost of the machinery. Alright? And you start making profit when you produce a certain amount. Got it? So this is how, in solving this sort of problem, optimization problem, you've got to think a little bit deeper. It's not on the surface, that's it. You've got to think about how you would solve a question like this. So, what I've done is, instead of doing a screenshot, I just sketch it. So I know this point here, when I first started, I'm out of pocket for minus $300. So as I produce more and more and more and more and more, I will make more money until I produce just under 82 units. If I produce 82 units, I will just sort of make a little bit of loss. But anything above 83 units, yeah?
Can profit be negative?
Sorry? Yes, that's loss. Profit is negative, is loss. Yeah? Yes, profit is negative, is loss. So minimum profit occurs when n equals to 83. And the profit itself is $3.03. I should have used 2 decimal places.
So why isn't it negative 300%?
We are talking, it can be, okay, it's the way the question is asked. They want to talk about profit. Yes, I know negative profit is loss. They didn't ask you about the loss. So they want the minimum profit. So you've got to think about anything that's above 0. Alright, minimum profit above 0. So you've got the minimum profit is $3.03, maximum is $967.50. So this requires a bit of thinking now when you start answering questions like this. Alright? Now I would like you to have a read of example 2. Example 2 is actually from Nelson. I took it out because I knew it was one of the most difficult examples that I have seen and I've solved. So can you start reading example 2 please, before I show you how to solve it. Solving question 2. You need to know a few things. You need to know your speed and distance formula and time formula. You need to know your Pythagoras' theorem. You definitely do need to know your Pythagoras' theorem for that. So it's assumed that you know your Pythagoras' theorem. Alright? Okay, hang on. Before we go into that, I should have talked to you about this. Now, we've learned how to differentiate explicitly, which is find derivative of function in terms of single variable. Now, if an expression is dependent on more than one variable, substitution is required, which is the next question. Alright, we're going to talk about a bit of substitution. Here, let's think. You've got example 2, it's distance, speed, right angle triangle, Pythagoras' theorem. Alright? Trin and Soy set out from 2 towns. They travel on straight roads that cross at right angles. So right angles is important because you might be using your trig function, you might be using your Pythagoras' theorem. Although we don't differentiate trig function this year, next year you probably will have to do that. And they each walk towards town beyond their intersections. Trin is initially 15 kilometers away from the intersection and walk at 3 kilometers per hour. Soy is initially 10 kilometers from the intersection and walk at 4 kilometers per hour. Now, it did not say that the speed is constant at 3 kilometers per hour or 4 kilometers per hour, but in this situation, we have to assume that it is constant. Alright? It's the average speed, it's the constant speed that is walking. One is 3 kilometers per hour, one is 4 kilometers per hour. Alright? That is important. Alright. Now, you need to show the distance apart after 1 hour is given to that. Alright. Can you all focus on me for a minute, please? Focus, please. Everyone, look at the board. Technique of answering a question like this. Alright? Basically, this, if you cannot prove that, don't worry, go straight to use that equation for part 2. Alright? It is, you have to realize that if there are 2 parts, if you're asked to show something, that is going to be used in part 2. Part A, if you can't do it, stop it, don't care. Let's go straight to use that equation for part 2. Yep.
Yeah, did one slide when it's back, and then I used in part 2, and teacher was like, but you didn't show that equals to part A.
No, it should follow through because that's how the question is designed. Part A, if you can't do it, doesn't matter, just use straight in that formula. That should always be the follow through marks. Alright? Now, so you should actually draw a triangle. So I start off with 2 dots, Trin and Soy, and I have got a right angle because they're walking that direction. They are meeting there. And then the distance apart is just D, correct?
Yes.
Solving using Pythagoras' theorem. Keep going with the diagram. Write down the 15 kilometers and 10 kilometers so you know the distance. Right? Next step. You need to know this distance, diagonal, shortest distance between trains and so on. So what you need to do is think about the speed. One is walking at 3 kilometers per hour, the other one is walking constantly at 4 kilometers per hour. Now, read A. Show that the distance apart after t hours is given by this. So, t is already defined for you, t hours. Correct? So at any time t, train travel at 15, train speed is 3t, and soil speed is 3t. Therefore, the distance here to the junction is 15 minus 3t, and the distance from off soil to this junction is 10 minus 4t. That's not correct, so I've got to change that in a few minutes. All right, it's not travel. So the speed of train is 3t, and the speed of soil is 4t, and therefore the distance from the intersection point is actually, oh no, I can't do that. I'll change it a little bit later. The distance from the intersection point for train is 15 minus 3t, and that is 10 minus 4t. Do you agree with me? Yes? Now, can you then use your Pythagoras' theorem to find d? Can you do that? Of course. This is 15 minus 3t squared plus 10 minus 4t squared. You must know your binomial expansion. Alright? So, if you do that, this is the proof. D squared equals to 25t squared minus 170t plus 325. The trick is understand the question, be able to draw the diagram, use whatever you have learned. Like I say, maths is never compartmentalized. It will actually continuous. You need to know your knowledge from many years ago. Alright? Practical example, something like this. Now, so, hence, find how long it takes them to reach their least destination apart and the least distance. Alright, so you need to find the shortest distance of D. But the problem is you've got D squared. What are you going to do with D squared? If you root it on the other side, how are you going to actually do the first derivative of that? I haven't even taught you the technique of doing that yet. No. So, go back to the previous slide. Thank you. It's a good thing. If you go back to the previous slide, what did I say? If an expression is dependent on more than one variable, substitution is required. So we let d squared equals to something. See mine? Go to the next. So from here, oops, what do I want? Let p equals to d squared. Alright? So once you've done that, you therefore know p equals to 25t squared minus 170t plus 325. Substitution. You can't actually, you really don't want to do d squared and t. You don't want to derive that. You just substitute p. Substitution. And then straight away, you know what dp dt is, the first derivative. And can you therefore find the minimum? Now, you don't know whether it's minimum or maximum yet, but you can find that you can find t is 3.4 hours. Of course, t has to be positive, cannot be negative. Correct? So 50t squared equals to 170.
Wasn't it
50t. Oh, hang on, it's 50t, my fault. It is 50t. Oh, dear. What have I done there? I have no idea what I've done there. So that's not correct. That's not correct. T is that. So here, T and distance of T from intersection. Alright, same with this one. Alright, I'm just going to scratch it out. That's it. Alright. So T is 3.4 hours. No square. Alright. Now, can you try your sign test, please, to see whether it is a minimum? What is a sign test? How do you need to set it up? Mm-hmm. 3.4 and greater than 3.4.
So it's negative.
Set up your sign test. Alright, so this is how I did the sign test. And for t equals to 3.4, d squared is the minimum. Alright, instead of using d squared, you substitute p as d squared. Make life a little bit easier for yourself. I mean, there's nothing wrong if you write something like this. Is nothing wrong. D squared over dt. That's correct, but makes life a little bit easier. You're more used to having something like dp dt. Alright? Do that. Substitution. And then, of course, you need to find out the distance. And the distance is d is plus or minus 6. And you know that it has to be positive. The least distance apart is 6 kilometers. And the time taken is 3.4 hours, or 3 hours and 24 minutes. Like I said, this will probably be the most difficult question you would encounter. And if you've got a question like this, I would recommend in the exam leave it to the last. Alright? Don't leave it, but leave it to the last. Or don't worry about part A, go straight to do part B. If you're not sure. Yeah, when we set questions for exam and stuff, we try not to. We'll try to give you some marks. So you try to get difficult question. You can use the equation in part A or part B, and then go to part C. I mean, honestly, last year was it last year or 2 years ago? There was one question that first part was so difficult to prove, but the formula is given, and only about from memory was about 20 kids who knew how to do it because they used the second part and they got that marks, and only about 1 or 2 got part A correct. All right, let's move on to the last one. All right, last one is a measurement question. A closed rectangular box has a volume of 10800 centimeter. The height of the box is 3 times its width. Use calculus techniques to find the dimension. To do decimal places of the box that will minimize the surface area. All right, this is another difficult one in many ways. I have drawn the rectangular box. Now, sketch that in your book, please, and I'll go through and explain it carefully to you. All right. Let's see. We know that one, okay. The other thing is I highlighted here, minimize. I want to minimize the surface area. You should be able to work out surface area based on the height, the width, and the length, correct? How do we do it? First, we know the height and the width. Now, the way I've defined it in a diagram. So I know that this is x, and I know that that's 3x, correct? The height is 3 times. The length, I have no idea what it is, but I do know the volume. I have no idea what the length is, but I do know the volume, correct?
Correct.
Yeah? So, what I'm going to do is to assign the length as L. All right. This is coming back to substitution again. So, how do you find the volume of a rectangular box?
You times them all together.
Thank you, times it all together. So, what do you have? 3x squared, L equals to 10800, therefore L equals to 10800 divided by 3x squared, or 3600 divided by x squared. Now, you've got L in terms of x. Correct? See? Use the information given. You know the volume. You know one is 3 times the other, you don't know the other one. But you can relate this to that by using x or w or whatever. I don't mind. Now that I've got L in terms of x, can you therefore work out the total surface area?
Yes.
In terms of x. Alright? A in terms of x. How would you do that? I'm not saying anything yet, let you try it out first. I'll give you time to try that out. Just finish at A, the total surface area. A in terms of x. Just think A in terms of x. While you're doing that, since you've already done your test this morning, you could all have one of these. Got it? What, you haven't done your area yet. Area in terms of x and L. X, or in terms of x, not L, sorry, L, x. A in terms of the total surface area in terms of x.
I think people don't like orange stuff. Orange.
And you have to simplify it. I don't think people like orange. Alright, next. Now, see, this is how I do it. It's sort of a little bit more complicated, but you do know that is 2 of this area, 2 of this area, and 2 of that area, correct? So it's 3x squared, L times x, L times x, L times 3x. And then expand and simplify. Expand and simplify. You got a and x. Now, can you do the first derivative of that now? Of that? Of course you can, come on. So once you've got up to this point, it's all your skills. Alright? Bringing back your skills, how to do your first derivative. How do you differentiate dA dx? Differentiating dA dx. What's next? If it is minimum. So dA dx has to equal to 0. How do you solve it?
You tell me so.
Oh, come on. You got your classmate in front of you.
Ah, I thought that
Equal to 0.
Use your classmate to solve it. I'm not even going to solve it manually. I've got my classmate in front of me. So you know dA dx equals to 0 because you want to find the local minima or the local maxima, and therefore 12x minus 28800 over x squared equals to 0. Now, class pad. What's class pad for?
math.
13.388659.
Okay, 2 decimal places.
13.39.
13.39. Alright? It says here use calculus techniques to find the dimension 2 decimal places of the box. Alright? Now, however, you cannot just assume that that is the minimum. You've got to use a sign test. That is what we are looking for in terms of the test or exam. I want to see all of you to be able to do the sign test and tell me that this is minimum. Alright, when you go out to work in real life, when you write a report, when you convince someone, you must always give evidence. If you cannot just say that it's minimum, there's no evidence. The evidence has to be there. So remember, when you start working, you want to convince people for certain things, you always must have evidence. So the evidence here would be your sign test. Alright? And therefore, once you've done the sign test, you can conclude that this is a minimum. And after that, you can find the value of 3x and the value of L. Correct?
Yes.
Now, this step is important. If you don't do this step, nobody knows it's a minimum. Nobody would know there's a minimum. You must show the minimum.
But so how do you do that like quickly, like you did in your end, like 13? What?
You solve it like a really small number and a really big number.
Now, of course, you want to check this. One number less than x, you cannot use 0, correct? You know that x cannot be negative, so you use 1. So 12 minus 28800 is negative. You use 1. And then the other one I would use is 10. Okay. Oh no, not 10. 10 is still whatever, I'll use 100. Because 100 is a lot bigger than 13.39. So if you use 100, you know that 28800 over 100 squared will be a small number. 12 times 100 will be 1200, so therefore it's positive.
Wow. So could you just assume that it's positive because of its...
No, you can't. You got to check. You got to check. Because you may have point of deflection. This one you don't.
Did you say for these?
Yeah, but this, you still have to do that. You still have to do that. Just, you see, like I say, some teachers teaches the student use one number to check, but I'm teaching you a technique so that you just use number on each side to see whether it's positive or negative. Alright? The evidence is there, and therefore, bingo, you can find the dimension to 2 decimal places. And again, I bet you, in the exam itself, heaps of people will just stop at there and did not find the other 2 dimensions. Alright, you got to be careful when you answer questions in the exam. Alright, what you're doing in all this, it applies to real life as well. So, give evidence when you're writing a report, and when you're writing a report, or if you're talking about some engineering design, you must always realize that you have to give all the dimension. Alright? It's not just an exam. In real life, you've got to do that as well. I know it's a long lesson, and I am actually going to finish here. And tomorrow, you have time to do work in class.